Let's give ourselves a little bit more practice with discrete probability distributions or probability mass functions. So let's define our random variable. Let's just call it x again. And let's say it's equal to the roll of a fair six-sided dice. Six-sided dice. So just a regular type of die that you would use to play Monopoly or something like that. Let's draw its probability distribution. And I encourage you to try to draw it on your own before you see how I draw it. So let's, on the vertical axis here, so the vertical axis here, this is going to be the probability that we get any particular outcome. And then over here, or the probability we get each outcome, here we're going to put all of the outcomes. So the values that x can take on are going to be, you could get a 1, you could get a 2, a 3, a 4, a 5, and a 6. Now, what's the probability of getting a 1 if you roll a fair six-sided die? Well, it's one of 6 equally likely outcomes, so you have a 1/6 probability. So it's 1/6. So that's the probability of getting a 1. I'll draw it as a little bar chart here. So you have a 1/6 probability of getting a 1. Now what's the probability of getting a 2? Well, once again, it's 1 out of 6 equally likely outcomes, so it's once again 1/6. So I'll just draw it just like that. It is 1/6 again. And same thing for 3. It's 1 of 6 equally possible outcomes. So there's a 1/6 probability of getting a 3. There's a 1/6 probability of getting a 4. There is a 1/6 probability of getting a 5. And there is a 1/6 probability of getting a 6. My little markers here got a little bit off center, but hopefully you get the general idea. So that's 5, and that is 6. Now, the way that I've drawn it right here, is this a legitimate probability distribution? Well, sure it is. You see that you have 6 equally likely outcomes. Each of them have a 1/6 probability of occurring. The total, I guess you could say mass here, if you say that there's 1/6 in each of these buckets, it's 6 times 1/6, it's 1. It all adds up to 1, which makes sense. You have a 1 or 100% probability of getting one of these outcomes when you roll a fair six-sided die. Now, when you have a probability distribution where every outcome is equally likely, like this, so notice every outcome is equally likely, there's a word for it, just so you know it in the future if someone says that you're dealing with a uniform distribution. And you can have a discrete uniform distribution. That's what we have in this case. And in future videos, we're also going to see continuous uniform distributions. Now, my question to you, let's say that someone took one of these six-sided die and erased one of the, so you have one side of the die that looks something like this, where it has 2 dots on it, and someone was able to erase it. So that side only has one-sided. So now we're not going to deal with the roll of a fair six-sided die. It's still going to be a six-sided die, but it's no longer fair anymore. It's no longer fair anymore. It's the two side replaced with another one side. Another 1. So you have 2 sides of this six-sided die that are 1, and then you have no side that has a 2 on it, and then the rest haven't been changed. You have a 3, a 4, a 5, and a 6 side. For this random variable, what would the probability distribution now look like? And I encourage you to draw it right now. So you might guess that it will no longer be uniform. So let me remove this just so that we don't get confused. And let's think about it. What's the probability for this new die that I get a 1? Well, there's now 2 possible ways that I can get out a 1 out of a 6. So there's now a 2/6 probability that I get a 1. So let me draw that. It's now a 2/6 probability that I get a 1. So it looks like this. I'll shade it in. So this right over here is 2/6, or I could write that as 1/3 if I like. Now, what's the probability of getting a 2? Well, it's impossible for me to get a 2 now. There is no 2 on this die. I've removed the 2. It's now a 1. So there's nothing here. Let me delete all of this. There's nothing here. I have no probability. I cannot get a 2. No face of this die has a 2. Now what's the probability of getting a 3, 4, 5, or 6? Well, those are unchanged. There's still one side that has a 3 out of 6 equally likely sides. So you have a 1/6 probability of a 3, a 4, a 5, or a 6. So the rest stays unchanged. So once again, we've constructed another discrete probability distribution. It is no longer uniform, and it's a little bit more interesting. This is the role of this not-so-fair 6-sided die. You have 2 sides that have a 1 on it and no side that has a 2.